In this video, we'll answer the biggest question of the millennium, why we use RGB for screens and CMYK for print, and why we will never be able to use RGB for print. I know that was a little bit of exaggeration, but let's get started. Have you ever seen a rainbow? Even the picture of a rainbow will do. Well, that's what a color wheel is, if you're wondering. In this color wheel, as you can see, you remember the colors of the rainbow? What were they? Vibgyor, violet, indigo, blue, green, yellow, orange, red, right? So look at the color wheel. Violet, indigo, blue, green, yellow, orange, red, right? Arranged in a circle. That's what a color wheel is. Now, watch. Look at the opposites of red, green, and blue. The opposite of red is cyan, right? The opposite of blue is yellow. The opposite of green is magenta, RGB. The reason why RGB is used for screen and CMYK for print can be understood by representation of white in screen and in paper. You see, in screens, red, green and blue as RGB, different proportions of red, green and blue are used to show or depict the color that you desire or the screen shows. In print, the combination of cyan, magenta, yellow and key, which is black, the combination in different proportions are used to show millions of colors. Let's look at how white is represented. So if I pull down my info panel, as you can see, I take my eyedropper tool, and if I just hover over, you see the different values of RGB for different areas. So if I'm in the red zone, you can see the value of R is 255, that is maximum, and if I move in, the value of green and blue change depending upon the position I'm in. If I go over an area which is purely red, the values of R would be 255, green would be 0, and blue would also be 0. So somewhere here is the area. The value of extreme green, watch, the value is 255, red and blue are small. If I move over exact green, the value of red and blue would be 0 and green would be 255. Now watch how white is represented. Now if I move towards white, you can see that the value of red, green and blue is moving towards 255, and 255 is the maximum number of red, green and blue. Why? Because red, green and blue is shown by 8 bits each. Right? 8 bits of data. And if you know computers just a little bit, in 8 bits, 255 is the maximum number that you can represent. As I discussed to you before, CMY is the opposite of RGB. K is for darkness, K is for black, the amount of dark or bright the color is. Now watch, if you had to represent white in a screen, if you zoom in, take in a magnifying glass, and also as we saw in the info panel, the values of R, G and B becomes totally white, 255, 255, 255. It becomes totally bright because it is a light. Your screen is not a color, it's a light, right? Now, if you have a watercolor or oil color, if you have that, and if you mix RGB in similar proportion, I'm sure, I guarantee that it will never become white. However, wonder how white is represented on a paper? No color, right? When you have to represent white in a paper, there's no color in it. So, when R is 255, what's the value of cyan? Since cyan is opposite of red, the value of cyan will be 0. The value of magenta would be 0. Because magenta is the opposite of green, and if green is 255, then magenta is 0, because magenta is the opposite of green. And henceforth, Y will also be 0. And since there is no brightness, K will also be 0. If all the values of CMYK is 0, what is the amount of color that will come out of the printer? I'll see you guys in my next video. Till then, stay tuned and make sure that you keep creating. And also, don't just subscribe. Click on that bell button so that you don't miss anything. Thanks for watching.